next session on finite element analysis. In this session, we are going to discuss about steps involved in FEA. Finite element analysis is a numerical technique used for solving engineering problems by dividing complex structures or systems into smaller, simpler substructures called finite elements. These elements are connected at points called nodes, forming a mesh that represents the entire structure. FEA is widely employed to analyze and simulate the behavior of structures subjected to various physical conditions such as mechanical loading, thermal changes, and fluid flow. So you can apply FEA to any type of problem which could be subjected to some sort of load, that is some structural analysis. It could be subjected to certain temperatures or heat flow, so that comes under thermal analysis, or you can solve a particular fluid flow problem, that is a fluid mechanics. So all these things can be solved in FEA when you divide the entire body into elements and nodes, that is you form some mesh. Here is a brief overview of the key aspects of FEA. The first step in FEA is discretization. The continuous physical domain of a structure or system is discretized into a finite number of smaller elements. That is the first step of solving FEA, wherein we take the entire body and we divide it into a mesh. Nodes are defined at the corners of these elements, and the behavior within each element is approximated using mathematical functions known as shape function. So you can basically divide the entire structure into mesh, wherein the corner points will be called as nodes, and two nodes will be used to define a particular element. And each element will have shape function at its nodes. So this is a continuous system, as you can see on an object. You can divide this into mesh. You can see this is a mesh that is created. These four corners are nothing but the nodes. So you can see here it's shown these are the nodes for a particular element. This rectangle is one element and these are four elements created. Discrete system is nothing but the discretization process. So this is another one. See, the object is of this trapezoidal shape. So you can discretize this with the help of triangular elements. Here we were using rectangular elements to discretize. Now we are using triangular elements. That is easier to discretize, so we are using these kind of shapes. So for a triangular element, these will be the nodes, the corner elements, and the central ones will be called as the element, the red one. You can see these are all elements. Mathematical formulation is the next step. The governing equations that describe the physical behavior of the system, example equilibrium equations, heat conduction equations, are formulated for each element based on the principles of physics and engineering. For example, if you talk about the heat conduction equation of a long fin, then the equation is d square theta upon dx square minus m square theta is equal to 0. As you can see here, this is a long fin. This is its governing differential equation. So we are going to use the governing differential equation. We will study its solution, and from the solution we are going to derive a particular element matrix equation that will be used for solving the problem. Or suppose if you talk about the Fourier's equation, that is Q is equal to Ka dt by dx. So that will help you go to the element matrix equation of Ka upon He 1 minus 1 minus 1 1 U1 U2 is equal to P1 P2. So this is a equation which you can derive from using Fourier's equation. Same way you can use this equation to solve the fin problem. Next comes the step of assembly. The equations for individual elements are assembled into a system of equations that describes the behavior of the entire structure. So suppose if I use the equation as I told you, the E.M.E, that if you combine together for all the elements present in the system, that will be the step of assembly, wherein you form the global matrix equation. This process involves assembly of the global stiffness matrix, mass matrix, and load vector. So basically, you are going to assemble all the three of them and you form the total equation which is called as global matrix equation. Then comes the step of solution. The system of equations is solved numerically to determine the unknowns such as displacements, temperatures, or other relevant field elements. So you can figure out whatever you want. Suppose if you find out displacement, then you are using the module of static structural of ANSYS. If you want to figure out temperatures, then you are using steady state thermal analysis, or maybe you are studying the transient thermal analysis, and you are going to figure out the temperatures over the body. And other relevant field elements means you can talk about frequency. That means you're talking about modal analysis or random vibration analysis, or you're talking about explicit dynamics. So these are the various modules which are used for specific purposes. Various numerical methods such as the direct method, iterative methods, or sparse matrix techniques can be employed for solving the system. Now, when I talk about these techniques, this is about the FEA method, the numerical method of solving the problem. Whatever you study in the numerical method is actually present at the back end of ANSYS. So it is very important to know how to solve using the FEA method. Next step is the post processing. This is the last step actually. Once the solution is obtained, post processing involves extracting meaningful information from the result. Once you obtain the results of temperature, displacement, stress, strain, whatever you obtain, it is important to understand the meaning of the colored results obtained. Also, you need to interpret the value that you have got. It is not about just obtaining some colorful results. It is also important to interpret what is the meaning of the value that you have obtained. For example, if it is showing zero stress, it simply means that it is a point where there is least resistance. And when you get maximum stress, it is a zone where you have applied, say, fixed. So that is a way of understanding the results. Engineers analyze and interpret the results such as stress distribution, deformation, temperature gradients, etc. to assess the performance of the structure or system under different conditions. Last, we'll discuss about the key points of this lecture. FEA is a powerful tool used in various engineering disciplines, including structural engineering, mechanical engineering, aerospace engineering, civil engineering, and more. It enables engineers to predict and optimize the behavior of structures and components, leading to more efficient and cost-effective designs. FEA is an integral part of the product development process, allowing engineers to simulate and analyze the performance of designs before physical prototypes are built. So this is extremely important line. There was a time when FEA was not there in the market, and people used to go for destructive testing, that is manufacturing something and then testing what would be the life factor of safety and everything would be calculated. But now we are in an era where you can use softwares and you can directly figure out what would be the life or what is the factor of safety, what is the stress, strain, deformation, or what will be the maximum temperature that a body can sustain. Everything can be just calculated before making of the prototype. So basically, you save the material cost and also the labor cost and every other cost that is involved in making of a prototype, testing it, and it's a destructive one. You just destroy it. It's of no use. So you need to go for analysis such that it helps you understand if there are any changes to be made in the design so that it can perform better beforehand. So once you've made the design, the testing is done, you're sure that your product will now be safe to build and use. So you can directly go for manufacturing, a final testing, validation, and use in the market. So basically, your steps involved also reduces, and so does the cost. So with this, I end the session. I hope you have understood the steps involved in FEA process. If you have any doubt, please write to me in the comment section. Don't forget to like, share, and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.